what this question is asking, we want to predict the Diels Alder products out of these two reactants. There is a diene, and there's a double bond with the electron withdrawing groups. Electron withdrawing groups we see here is a nitrile, that one with a pi system. So this one, we are expecting end of product recombination. So we're going to draw these things. So this diene drawn here, and then I kind of draw this dienophile underneath. But as I said, 50% will be approaching from the bottom side, 50% will approach from the top side. I'm only going to draw the ones that are coming in from the bottom side, but assuming that the top approach will just make an enantiomers, which we will not draw, that has to be assumed. So when you draw the answer for the question like this, it's totally up to you where you're going to put this, the dienophile approach. You don't have to make it come to the bottom. That's what I normally do. But you can also make it come to the top. You will just make an enantiomer. Anyway, these two molecules will now coming together, and then they're going to make a bond between these two carbons. This pi bond is going to be used to make a single bond between these two. Now this double bond is going to move inside, and that double bond is going to come out and make a double, single bond. That makes a cyclohexene. And then what is shown here, nitrile is placed endo positions, right? That's basically what makes the endo products. And this is going to be the products of the Diels Alder reaction out of these two molecules. And this is kind of perspective drawing. I hope that you get used to it, but if you don't want to draw this way, you can draw the regular loose structures with the wedge and dash. Then this is going to be same drawing of that molecules. If you make this nitrile come from the top, then this nitrile is not going to be dash. It's going to be wedge. It's going to be both wedge. And that will be the just make a, that's not a long product. That's just enantiomers. And it just forms together. You can draw that one as an answer, but you don't have to draw me both. That's what I'm saying. You can draw me either. So that is the first question. Second question is kind of looking at things a different way. We want to make this, and then I'm asking you to find out what would be the reactant, suitable reactant for the reaction. Then obviously we are in the topics of the Diels Alder reaction, so I guess you are trying to find out which two reactants you need to make the Diels Alder reactions. To make the Diels Alder reaction, I remember that being the diene with a 4 carbon, and then dienophile with a 2 carbons. Dienophile typically carries electron withdrawing groups. So you can find any 2 carbon in the 6-member ring, but this is electron withdrawing groups. That's more likely to donating groups. So the 2 carbon dienophile probably should have this electron withdrawing group. And then the other 4 carbon should be the diene, right? So we need to find out how you're going to break the molecule. So 4 carbon with a 2 carbon, that's why we says 4 plus 2 cycle addition. Having this recognized, this part is going to come from the diene, and that part is coming from the dienophile. Now we have to draw them out. So this looks like that. That looks like this. So will these two the reactant to make that product? Because it looks like I just show that is 2/3 of the molecule here, and then 1/3 of the molecule there. But if you choose that way, that is wrong. That is something that you need to think about. Diels Alder reaction, use of pi bonds. So what is the reactant that you need to see? These are diene. That's not how diene looks like. Diene is a 2 double bond conjugated. And then on these electron withdrawing groups, you see the double bond. That means that you made like a double bond here. But remember that the dienophile use a pi bond to make a single bond. So after using pi bond, it becomes a double bond. So that means that in the beginning, you have to have triple bonds. When you have a triple bond, and one of the pi bonds is going to make a single bond, so you're going to have a double bond remaining, right? And then also these pi bonds in the conjugate system will move it around, make the double bond goes in the middle. So you have to remember the mechanism to break them out in a proper way, so you can identify the proper reactant to make a useful reaction.